Hi, my name is Rick Fontenot, and today I'm going to present a case study for our data science course at SMU. DDS Analytics is a company that specializes in talent management solutions and provided us with a large data set about employees. They've asked us to identify factors that lead to attrition, and we'll present a model to predict attrition. We'll also look at some interesting trends observed between job roles and present a model to predict salaries. We started by taking all of the variables available and looking at the top factors that lead to attrition. We did this by ranking p-values from chi-square testing on our categorical variables and t-testing on our numerical variables versus attrition. And from this, so the top factors that came out was overtime. Employees who work overtime have a 33% higher attrition rate. Job role is also a strong factor, and within all of the job roles, we noted that sales representatives have a significantly higher attrition rate. On the flip side, manufacturing directors and research directors have a much lower attrition rate than the bulk of the other job roles. And intuitively, higher paid workers also have a lower attrition rate. In all, there's about 18 variables in the set that do have some significance in their difference between the attrition categories. Working down to one of the other interesting ones with significance is that the attrition rates are much higher for employees with less than 3 years of total working experience. Once you get up to about 6 or 7 years, the attrition in the workforce, the attrition rate levels off and averages about 10%. Using all of this information, we built a naive Bayes classification model, which uses probabilities from all of these predictor variables on the attrition rate and combined together to try and classify for each employee with that information. Before building the model, some of our pre-processing, there are a number of variables that didn't exhibit normal distributions, so we performed a log transformation on those. And then we built an initial model using all 18 of the predictor variables that showed significance with a p-value less than 0.05. From that starting point model, we performed a number of iterations to see if we could improve the accuracy and reduce the error. We did this by removing variables, predictor variables that were correlated with each other. For instance, department and job role are highly correlated, so we removed that. In that instance, it did not improve the accuracy. But when we removed job level, which is highly correlated with monthly income, the accuracy did improve. We kept stepping through iterations, removing variables that were correlated. Some improved, some did not, and some were additive and some were not. In the end, we settled on a combination of these iterations that improved the accuracy to 90%. With that model, the top factors within it were overtime, the job role, and the monthly income. And we used that model from our training set and validated it with a test set. And on the testing set, our accuracy was still an 85%. Looking beyond that model, or actually through the exploratory data analysis while preparing for that model, a notable observation or interesting observation that we saw within job roles is that sales representatives are much more likely to be single. On average, 49% of sales reps have never been married or divorced, versus 31% for the overall population. Within that, we also observed that sales reps who married or divorced have lower job satisfaction than other roles. Next, we took all the same information to build a model to predict salary. We used multiple linear regression and started with all the predictor variables available. Once creating that base model, we use selection methods, the forward selection, backward selection, and stepwise methods to look for the most important and significant variables without increasing the error rate by including too many. Through all three of these methods generally settled on a similar list of variables. And so we started with these 8 parameters, which include job level and the job role and the total working years, as well as a few others. Then we similarly worked through iterations to simplify by removing variables in the model that showed little significance with p-values greater than 0.05, and settled on a model with 6 variables, and it had an error rate of $936. We then used that model and validated it with our testing set, and which gave or showed an error rate of $1,115. So in conclusion, and some interesting things to explore further, would hiring more workers and reducing overtime reduce attrition? Since inexperienced workers have high attrition, could additional training help? We know higher pay reduces attrition rate, but what's the cost-benefit ratio? What is the cost of attrition? And why do sales reps turn over more than other jobs? Is the fact that they're not married and divorced a cause or an effect? Are these two related? And we also saw that with the top 3 factors, job level, job role, and total working years explain 90% of the variation in salary. Thank you.